Okay, so let us try to determine the value of y1 and x1. So this is your y1 and that is now your x1. That is your point O and that one is now your point B. The radius of the plate is equal to 4 meters. So if you try to get sine of 40 degrees, that is equal to y1 all over 4 meters. So your y1 in here is equal to 4. We have sine of 40 degrees. So we have cosine of 40 degrees is equal to x1 all over 4 meters. So your x1 is now equal to 4 cosine of 40 degrees. Now, let's try to get this, the other one in here, x2 and y2. So again, this is along the x-axis. And this one is equal to 30 degrees. It's along the x-axis, so this is the x-axis. So we have your point C. So this is now your point C. That is now the origin. So if you try to get now this point, this is therefore your, okay, so that is now your, so that is your point C. Goes that way. Okay, so it's your point C. So I will consider this point in here as now your x sub 2. From this point up to that is x sub 2. So that 1. And this one in here is now your y sub 2. And we still have the radius of the plate, which is equal to 4 meters. Again, this is now your 30 degrees. Now, if you're going to get a sine of 30 degrees, this is equal to y sub 2 all over 4 meters. So your y sub 2 is now equal to 4 sine of 30 degrees. Again, cosine of 30 degrees is now equal to x sub 2 all over 4 meters. So your x sub 2 is equal to 4 cosine of 30 degrees. We have now 4 cosine of 30 degrees. Now, assuming that the resultant lies at this point, so that you have the x coordinate and the y coordinate. So how are we going to determine the x coordinate and the y coordinate of the resultant force? So we now have moment of the resultant force about the x-axis is equal to summation of moment of all the forces in the original system about the same axis. So let us try to consider counterclockwise moment as positive. So counterclockwise moment is positive. So your R, based on this diagram, your R is going clockwise. So we have negative R multiply this one by X. And this is therefore equal to 25. So we're getting 25 multiply this one by y1. So we have 25 multiply this one by y1. Okay, so plus 35 multiply this one. This is the moment arm about the x-axis. And that is equal to 4 meters, which is the radius of the plate. And then this one in here is going counterclockwise. So we have minus 40 clockwise. Okay. So minus 40, multiply this one by the moment arm is now about the x-axis at this point. Okay, so it goes clockwise. So this is the x-axis. And therefore, multiply this one by y2. And your y2 is equal to. So the resultant force is 100 kilonewton. So this is minus 100 multiply this by x is 25. And your y1 is 4 sine of 40 degrees plus 4 sine of 40 degrees plus 35. Multiply this one by 4 minus 40. And your y2 is 4 sine of 30 degrees. And therefore, your this is really. So that is your R multiply this one by Y. So that is the moment arm about the x-axis. Hence, the value of Y. So we have negative 100Y is now equal to 11. This is equal to. Okay, so I'm just going to calculate it immediately. So your y in here is now equal to negative 1.243 meters. Hence, your y is equal to 1.243 meters. So it is back. Okay, so this is to the left of point O. So the resultant is 1.243 meters to the left of point O. Now, let's try to get now moment of the resultant about the y-axis is equal to summation of moment of all the forces about the y-axis, taking again counterclockwise moment positive. So we have the resultant force. So your R is going counterclockwise about the y-axis, and that is equal to x. Multiply this by x. And this one in here is now equal to 25 by x of 1. That is 25. Multiply this one by x of 1. So, again, this is going, okay. So, we have your 35 kilonewton has no moment about the y-axis because it intersects the y-axis. So, we have minus 40. So, we have minus 40. So, this is about the y-axis is going clockwise about the y-axis. So, minus 40, multiply this one by x of 2. So, your R in here is 100x is equal to 25. Your x1 is 4 cosine. So, that is x1, 4 cosine of 40 degrees minus 40. And your x of 2 is 4 cosine of 30 degrees. And therefore, the value of x is equal to, so we have negative 0.62 meters. And therefore, the value of x is now equal to 0.62 meters. It is back of O. 62 meters back of point O. Now, so if you try to take a look at this point, so we have now, so this is the 4, okay, so I'm going to get the circular plane. This is now the circular plane. This is your point O. So we now have your X. So we have the Z-axis at this point. So this is now the Z-axis. We have the Y-axis. And then we have the X-axis. So this is the X-axis. Now have your X-axis. Hence, the resultant, therefore, is acting at this particular point. So this is therefore the resultant force R. That is the resultant force R. And therefore, so we have the resultant force R, which is 1.23 meters left of point O. So we have 1.23 meters left of point O. So we now have the resultant force R. So this is the location of the resultant force R. So this is now the resultant force R. So this is your Y. Is this one in here is supposed to be your Y. So that is now your Y, which is 1.23 to the left, 1.243 meters to the left of point O. And this one in here is now your X. So this is now your X, and your X is equal to 0.62 meters back of O.